Now, in this video, we're going to answer the following question. For the cuboid below, find the length of AB. So we're given a cuboid. A and B are corners marked on the cuboid. The dimensions are the height is 8 centimeters and the base is 3 centimeters by 4 centimeters. I'm going to mark on two additional corners as C and D. I'm going to join B and D together with a straight line. BD will be the base of a right angle triangle from which I can calculate the length AB. But in order to do that, I need to first calculate the length of BD. BD is the hypotenuse of a right angle triangle BCD. So I'm going to go ahead and draw that. So B, C, and D. B is given to us as 3 centimeters and CD is given to us as 4 centimeters. Now, if I recognize that this is a 3, 4, 5 triangle, I already know that the hypotenuse is going to be 5. But I'm going to assume that I didn't recognize it was a 3, 4, 5 triangle. So I'm going to go ahead and use Pythagoras' theorem to calculate the hypotenuse anyway. So the hypotenuse I'm going to mark on as x. And so x squared is equal to 3 squared plus 4 squared. 3 squared is 9. 4 squared is 16. And together they add to 25. X is the square root of 25, and the positive square root of 25 is 5 centimeters. So that's the length BD. Now I'm going to draw another right angle triangle so I can calculate AB. So this corner is B, this one is D, and the top corner is A. BD is 5, and I've just calculated that. AD is given to me as 8, and the side I need to calculate is AB. So applying Pythagoras' theorem again, I can write down x squared is 5 squared plus 8 squared. That's 25 plus 64, and that's 89. X is therefore the square root of 89, and the positive square root of 89 is 9.43 centimeters. So the answer to the question, find the length of AB. AB is 9.43